Hi, everyone. My name is David Boike, and in the previous webinar, which you can still watch online, I built a complete NServiceBus system from scratch. That demo included how to send messages, do publish, subscribe, and orchestrate long-running business processes with sagas. But in the end, it was still a demo. Today, I'm going to take that same code and elevate it to something more production ready. This is the exact same code. The only things I've done to it while you haven't been watching are I updated it from .NET 5 to .NET 6. And so I'm using Visual Studio 2022. And I've updated the NServiceBus dependency from version 7.5 to 7.6. So while I do have a plan for today, this is still live coding, which makes me either stupid or crazy, or maybe some of both. So once again, I've got my colleague, William Brander, here to save me in case I forget a using statement or a semicolon. Say hello, William.
Hi, everyone.
All right, let's get started. The first thing I want to do is show you something I had prepared for the last webinar, but didn't have time for: how to deal with processing failures in your system, which is going to happen in real life, and you need to be ready for it. This is also one of the most useful features of message-driven systems in general, and especially in NServiceBus systems, because your system can be ready to deal with messages failing, and your front-end users never even really need to know anything bad happened. So we've got our platform tools, which include Service Control and Service Pulse, which normally, if you were already using a full message transport, you would install as a service on some server in your system. But since this project is still using our learning transport, we can use this package we have called the platform sample, and we can take a look at how it works. So let's do that. So in this solution, we're going to first create a console app. So .NET new console named platform. And we're going to add it to the solution. So .NET solution add platform. And then we're going to add the platform sample package to that. So that's .NET add to the platform project. I'm having trouble typing today. Package particular platform sample. Now we'll go to Visual Studio and it'll refresh and we'll have a platform project. Where is it at? It's right here. And you can see how adding the NuGet package for the platform sample has actually brought in a folder called platform here with Service Control and Service Pulse. These are kind of portable versions of the platform tools that we can use. So in order to actually run those, we need to open our program CS. And because we're in 2022, we're getting the minimal API stuff going on here. So I'm just going to get rid of all this. I'm going to say using particular, and then platform launcher dot launch. And we're going to want that project to actually run when we start the system. So I'm going to adjust the startup projects for the system. We already have the client UI, sales, billing, and shipping endpoints that we had in the last webinar already starting, but now I'm going to add the platform to that as well. So it's going to start. And now, in order to test this, what we're really testing is how to deal with messages that fail. So we need something to blow up. So how are we going to do that? Let's go to our sales endpoint and into the place order handler. And if you are not familiar with this, this is some code that we wrote in the last webinar. We were testing it to see what happened if there were intermittent failures back then. So you can review the old webinar, the previous webinar for that. So what we actually want to do here is we want to uncomment this code that's throwing an exception, boom. But where we were doing a random and we were only wanting it to fail 20% of the time, now we want it to fail always. So we're going to set that to anything greater than 0. So now we are going to demo it. Let's press start. The first time you press start is always the worst. Hopefully everything works. Everything's popping up. So if you're not familiar from the last webinar, we've got basically one console window for each of our endpoints. And then this is a new one for the platform EXE. And what it's doing is it's finding free ports for service control and to do all of the stuff it needs to do. And it's now waiting for service control to be available. It takes a second for it to start up. And then web browser opens, and this is the Service Pulse UI. And as we can see here, everything looks pretty good. Nothing's failing, nothing's red. So let's go back to, let's actually hide that now. And let's show our client UI and sales because, oops, I didn't want to make that big. Because client UI is where we're going to send messages from, and sales is the one that's going to fail. So let's actually, and I did it again. Let's press P to place an order. And oh, we see this boom happening over in the sales. Now we're getting a warning. Now it's saying delayed retry will reschedule message, blah, 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 after a delay of 10 seconds because of an exception, boom. And now we've already gotten it again. And it's saying now it'll retry after a delay of 20 seconds because of an exception. What it's doing is it's showing you our delayed retries feature. So we automatically do 5 immediate retries, but if that fails, then it goes into delayed retries. The reason for that is if you have something like a database deadlock, that's probably going to resolve itself on the very next retry. So you want to do immediate retries. But if you have something that's not quite a systemic failure, but not kind of an immediate retry thing, you want to wait and kind of back off a little bit. That would be for like, hitting a web service that happens to be restarting or something like that. So we do 3 sets of retries by default, and they increase in time each time. So we already did the 10 seconds and then 20 seconds, and now we're waiting for the last one, 30 seconds. And this is where I find out if I've vamped enough, and here I have, good. So now we've gotten a red fail. Message was sent to the error queue because processing failed to an exception. So we've exhausted all of our retries now, and the message has gone to the error queue. Well, service control, its whole job is to look at that error queue. And if we look back at this now, we see that that service pulse shows us that we have a failed message. And if we go and look at it, we can see that it's got this note that isn't filled in. I believe that we actually have a bug on that to hide that if that's not the case. But we can go and add an actual note to this and say some developer guy just threw an exception. So this is great for ops people to keep notes on these and find and talk about why they are and what we're doing with them and what the plan is, just kind of a little scratch space here. But what I want to do is I don't want to just retry one message. I want to show you what Service Pulse can actually do. I want to throw a lot more exceptions. And in order to do that, I don't want to wait for all of that. I don't want to wait for all of those delayed retries. So I want to show you how you can actually change that. So you can actually change the recoverability policy. We can go to the sales, we can go to the program CS. And here where we have our endpoint configuration, we can say var recoverability equals endpoint configuration dot recoverability. And then from the recoverability settings, we can say immediate retries. We want settings. We want the number of retries to be 0. Recoverability dot delayed. We also want that to be 0. And let's just look at some of the other settings in here. We have time increase. We can change the default time increase from 10 seconds to something else. We have a little callback for when a message is being retried. You can look at the number of retries. There's lots of things you can do in here. So settings dot number of retries, 0 for this as well. And that should be good. So now I can make a bunch of messages fail and they'll go immediately to the error queue and we can kind of get on with that demo. But I just kind of wanted to show you these retry settings and how you can customize that to what your endpoint is actually doing. Maybe you're doing something where immediate retries make no sense because it's just hitting web services. And if it fails, you really do need to wait for maybe even a minute. You can set an endpoint to do that. So let's push play again. And I'm going to make Service Pulse littler so we can see both at the same time. Oh, of course, this is the Service Pulse from the old one. We're still waiting for service control to be available. It'll pop up a new window. There it is. So we've got the one failed message right now. And if I can find the one that's our client UI, then I can send a bunch more messages. And you can see a bunch more messages immediately go to the failed queue. And you see all the boom, 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 boom in here. So when you have a message fail like this in production, what you really want to do is you want to fix it because these operations all represent, some user's order. Like they They maybe put in their information on the website and it sent a message and you already told them, hey, that's great, we're going to send you your stuff. But you have these failed messages on the back end. That's valuable business information and we need to recover that. We need to replay these messages after we fix the error. So what we're going to do is we're going to stop it and we're going to fix the problem. Luckily, we engineered the problem ourselves, so it's as easy as commenting out this code. And now we'll start the new version. And now back here, we'll wait for the new Service Pulse window to show up. Should take just another second for service control to be available. And there it is. So here we have our 18 failed messages. Now you don't have to replay each one individually, thank goodness. They're all organized in this message group. And so I'm going to bring the sales endpoint kind of front and center here, and also shipping, because that's kind of the end of the line in our system. After things go through shipping and through billing, then through sales and then billing, they go to shipping, and that's where the conversation of messages ends. So we're going to request a retry of this entire group. So it says retrying a whole group of message can take some time and put extra load in your system. Are you sure you want to retry this group of 18 messages? If that was 1 million messages, that would certainly be a little more load than 18. I think we'll probably be pretty good with 18. But we say yes, and it starts to initialize the request, and it's sending messages. And there is a little bit of a delay, which I can use to take a drink of water. And there go all the messages in sales and all the messages in shipping. So all of those things that were stuck in that system, all of those things that in a normal system would be a yellow screen of death, we were able to capture in an error queue. We were able to fix the underlying issue, and then we were able to completely resolve it. And the system is consistent all the way through without the front end users ever needing to know anything about it, which I think is pretty cool. That's one of the things I love most about NServiceBus. So next up, now that we've shown how to deal with failed messages, now we're going to show how to go to a real message transport. And in this case, I'm going to upgrade from the learning transport to RabbitMQ. So first, I guess I want to show you RabbitMQ. I have it running in a container here. So this is a brand new RabbitMQ instance that I instantiated using a Docker container. It's absolutely empty. You can see that there's 0 queues. And so we'll have to create some queues in order to use that too, but we'll see how that's done. So to update to an actual real transport, well, first of all, we need to actually remove the platform from starting up, because that uses the learning transport. So we won't be using service controlled service pulse for the rest of this demo. So let's just kind of cancel that out. All right, and next we need to actually add the RabbitMQ package. So we are going to do we are going to lose our PowerShell window. Back in our PowerShell window, we are going to do .NET add to the client UI package and NServiceBus RabbitMQ. And it does all of its NuGet stuff. And we are still waiting. Okay, we need to do the same thing for basically each of our endpoints. So oh, that's the old one. So I'll just type it again. .NET add sales package and NServiceBus.RabbitMQ. And you can tell all your friends how your favorite part about this whole thing was watching David type basically the same thing 4 times. .NET add shipping package and NServiceBus.RabbitMQ. Okay. So let's start. I'm surprised it didn't make me refresh. So let's start in actually the shipping endpoint, and let's go to program. And here, before we had, from the last webinar, use transport, learning transport. So we're just going to change that to RabbitMQ transport, and it's there in IntelliSense now that we have the package included. And now at this point, there are more settings that we need. But NServiceBus does a pretty good job of telling you what that is just by running it and dealing with the exceptions that it throws. So let's use shipping as a test case. So let's just run the shipping endpoint. We'll also look at what happens over here in the RabbitMQ window. So I'm just going to debug the shipping endpoint, and I'm sure we'll get an exception. And what is it? Transport connection string has not been explicitly configured via connection string method. Here's an example of what is required. Endpoint config use transport. It's telling us exactly what to do. I think that's a pretty good lesson about NServiceBus. We really try our best to provide good exception messages that tell you what exactly what you need to do in that situation. So listen to them, I guess, is my takeaway. We do get support cases where people ask, well, what's the problem with this? And we go, well, did you read the exception message? Oh, so let's do that. So I'm going to stop it, and I'm going to, in the RabbitMQ transport, this actually returns a variable. So we're going to make that var transport equals, and then we can do transport dot connection string. And my connection string locally is host equals host OS. I am running Windows within a virtual machine on Mac OS, and so the Docker container is actually on my Mac system, which is why I'm using this host entry. And then the username equals RabbitMQ, and the password equals RabbitMQ. And that's just how I have my container set up. And semicolons are always important. So now that we have that, let's try it again and see what it says next. So we try running it again. A routing topology must be configured with one of the endpoint configuration.use transport use something 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 routing topology methods. This is where you'd probably want to go check our documentation, and I'll give you a shortcut. Basically, in any new RabbitMQ system you're creating, you want to use conventional routing topology. I work here and I don't even remember what the differences are, but it basically describes how the transport uses the queues and topics and everything that's in RabbitMQ in order to route messages. So it's just something that you have to pick and that all of your endpoints have to agree on. So let's try it again. Just the shipping endpoint. And now we get to somewhere where I'm actually not happy with our exception message. And I'm going to be opening an internal issue on this because it says operation interrupted exception. The AMQP operation was interrupted. The close reason, blah, blah, blah. The important part is no queue shipping in vhost. I don't think that's very valuable. I think we should fix that, and I'm going to make sure we do try to fix that. But for this webinar, what this really means is that we aren't creating queues. If we look at RabbitMQ, and even if we hit F5 to refresh that, we've got no queues. Obviously, we can't connect to queues that aren't there. So NServiceBus has a feature called Enable Installers. And so what we want to do for this, while we're still in development, is we want to do endpoint, and it capitalized it. Thank you, not. Endpoint configuration.enable installers. Now, this is potentially something you only want to do in development. So this is something that would be almost good to put an if-def around, to only do it for debug, not for release. Because in development, you kind of want that rapid iteration. You want it to create whatever queues it needs. But in production, you should almost usually create your queues as some sort of a DevOps process, and then not touch them from each endpoint. But while we're in development like this, it's easiest to just do enable installers, and then the queues are created for us. So now let's run shipping, and let's see what happens. Well, we're running. It's not doing anything because we're not sending in messages. But if we go look at RabbitMQ, we see that a lot has happened in here. We have a shipping queue. We have an error queue to send those errored messages to. And we have all these NSB delay level queues. And this is our implementation of delayed messages natively in RabbitMQ. Each one of these queues represents a different number of seconds delay, where we do a bunch of binary math and give it a route to go through all of the queues, so that once it arrives out at the end, it has been delayed by the amount of seconds you intended it. So you can just kind of trust that those queues are there and not really look at them. The main ones are the shipping and the error. So we've got that. So that's good. Now we want to make the rest of the system work. So we need to copy our new configuration code to the other endpoints. So we've got the transport configuration and we've got the persistence configuration. And we're doing that because we have a saga in this endpoint. I'm just going to copy that to the other ones as well. We're still going to use learning persistence in this case, which is still storing it to the disk locally. If we were going for a full production setup, then we'd want to change that to something like our SQL persistence that stores that kind of stuff to a SQL database, or your persistence of choice. So I'm going to copy this whole chunk, and we're going to basically add this to the rest of the program CS files. So here is the sales endpoint, and I'll basically replace this with that. And platform doesn't matter. Messages doesn't contain, it's just messages. It doesn't contain any endpoints. The client UI, here's the transport part. So we'll replace that there. And then the billing, and we'll also replace there. If I did my copy pasting correctly, that should now work. And we can run it and we'll see if the system works on RabbitMQ. Here's our client UI again. Everything seems to be starting up fine. Let's check our queues. And now we can see we've got billing, sales, shipping, and error. There is not a client UI because the client UI application is a send-only endpoint. So it doesn't have an actual queue that it processes messages from. So now we can hide this and we should be able to send a message, and I'll put shipping here again, since that's where most of the activity happens with the saga that we have from the last webinar. So place an order. No. Immediate retry, because why? Oh, the process cannot access the file in the saga storage. That is unfortunate. And that is why you should not use development only transport or persistence in a production system, because sometimes things like that happen. So what I'm going to do is I'm going to go into File Explorer, and in the bin debug.net 6, this is the folder where that stuff gets stored. So I'm just gonna kind of blow that folder away and hope that we have a better time now. No, so here we go. We sent messages, they went through sales and billing, and we have this saga in the shipping endpoint that first it receives the order placed and it says, hey, we received order placed. Should we ship it? Well, it hasn't been billed yet, so the answer is no. And then we get the order billed and it says, hey, we've gotten order billed and now placed equals true and billed equals true. Should we ship it? And yes, order is placed and billed. It's time to ship. And then we also had a timeout in there that because saga was completed, there was no saga found for the timeout. And so it was basically just thrown away. Not a big deal. So we have taken a system from our learning transport to RabbitMQ in less than 15 minutes. So not actually that terrible. Next up, any production system should really have tests, and that includes your NServiceBus handlers as well. So we're going to show now how to do some testing on an NServiceBus saga. So we're going to actually make tests for the shipping endpoint for the shipping policy saga. I'm going to close everything else. This is that saga you saw me kind of narrating. Once we receive the order placed message and the order billed message, then we want to go into this process order method and ship it. So first, we're going to create a project for the tests. And yes, you can go away. So we want a new class library. So .NET, new class lib, name shipping tests. We want to add it to the solution. So .NET solution add shipping.tests. And we want to add a reference from shipping tests to shipping so we can actually test it. So .NET add shipping to shipping tests, a reference to shipping/shipping.csproj, and I hope that's the right path. And it seems that it worked. So now we can go look at that, and we'll have to reload because the solution got changed. And we can look at the project file. Now, remember I said I was using Visual Studio 2022 and .NET 6. So that means that the implicit usings enabled and the nullable reference types got enabled by default. We're gonna go ahead and go with that. So now we need to add the testing dependencies. So it's easier to just copy in this block of code into the file rather than try to do the .NET add reference for all 4 of these things and have me completely screw up typing each one of them. So we're using the Microsoft Test SDK, and we're using NUnit and the NUnit 3 test adapter. And then we're also using the package NServiceBus testing, which has a bunch of testing primitives that make it easier to test NServiceBus handlers and sagas. So if we save that and do a build, just to make sure everything's okay, and it is. So now we can start to do the tests. So let's actually rename class 1 to shipping policy tests, because the shipping policy is the thing we're going to test. So we've got shipping policy tests, and let's start a new test. So use the test attribute, and it's gonna fight me, and I have to do the usings and all of that fun stuff using NUnit framework. Okay, so we want a public async task should not publish after order placed. And what we want to test here is once we send the saga a message that we placed the order, we don't want to ship it yet. We want to also wait for order build. So that's what we want to check with this test. So these tests allow us to use the arrange act assert pattern. So we've got arrange, and so what we do is we basically new up a version of the saga. So var saga equals new shipping. No, thank you. News. I don't know what a new style parser is, but I don't want one. New shipping policy. And we probably need, okay, we got the using, cool. And we need to pre-fill the data. The data equals new shipping policy dot saga data. Just if you don't do this, it'll be null. So that's what we need to do. And then we need a context. So if you're familiar with NServiceBus message handlers, in fact, let's look at it. What we're going to be doing is we're going to be executing this method. So we need to input the actual order placed message and an iMessage handler context. Well, in real life, that's I don't even know what the class is in NServiceBus that provides that implementation. But for testing, we want something where we can make assertions after the test is over to see that everything we thought the method was going to do, it actually did. So we'll do context equals, it's a new testable message handler, context, and it's from using NServiceBus testing. Yeah. So if we peek at this, this is a class that implements, well, through this chain, it implements iMessage handler context, but it has all the stuff we're going to need. And it'll be more useful to look at it through IntelliSense. And we'll get to that in a second. And then we also need the command we're going to send into the saga. So var order placed equals new order placed. And I'll probably need another using. Still doesn't like me. Using messages. The order ID equals, we'll just call it 1, 2, 3, 4, 5 for the test. So that's our arrange step. Now we need the act step, which is a lot easier. We're going to basically await having the saga handle that message. So we're going to give it the order placed and the context. Now is the fun part, the assert part. So with the stuff that's in the context, we have a whole bunch of stuff in here, including the headers and the message being handled, the message handler, published messages, replied messages, basically everything that gets done with that message handler context in the handler gets reflected in here so we can assert on it. So we can get rid of this for a second. We can do assert that context published messages length is equal to, not 1, 0. We don't want anything published after we only received one message. And we can kind of change this with, should not publish messages yet. We could also maybe assert that context dot sent messages length is equal to 0. Should not send messages. That's a bit of a trick there, as I'll show you in a second. So let's go to our test explorer and let's try this. So let's run it. And it fails, but why? Let's expand that a little bit. Should not send messages, expected 0, but was 1. What's going on here? Well, it actually turns out that sent messages includes timeouts, and the shipping policy does register a timeout on the first message. And so that can be a little confusing. It's also available as a timeout property, and that's probably where we want to check. So this isn't actually a good assertion. Unfortunately, that's just something you kind of need to know about how sagas work, that messages with a delay are essentially sent messages. So instead, let's replace that with assert that context.sent messages.length is equal to 1. And let's add the description, timeout is sent message, should not send others. And then let's actually dive down into that as well. Let's actually say, let's try to get that timeout, which we can do. Let's say timeout equals context.timeout messages. And this is only messages that are timeouts. And let's say, let's do single, which if you're familiar with the link method single, that will throw an exception if there's more than one. And now let's say assert that timeout within is equal to time span from seconds. And now let's look in the shipping policy where it does that timeout on the handle order placed message. That's actually a timeout of 5 seconds. So that's what we want to assert, from seconds 5. Now if we run this and I have the right number of parentheses, I believe that should be green. Okay, cool. We have our first test. So now let's go a step further and let's test order build. And I know some people are a little bit religious when it comes to how much you should test in a unit test. I certainly don't want to step into that today, but for the sake of showing how something will work, let's make another test and let's do public async task should publish after both events. So let's do our range again. And this time we're going to basically set up our range as kind of what our state was at the assert of the last one. So we're going to do say var saga equals new shipping policy. New line, please. And that the data equals new shipping policy saga data, but we want to pre-fill that placed equals true, which is what the saga data should look like once the placed order placed message has come through. So then we still need a context, which I'm going to just copy this one from up here and paste it down here. And then we need the order build that we're going to use. So order build equals new order build. And we want to use the same order ID equals 1, 2, 3, 4, 5. So now we can go to the act phase where we do await saga.handle order build context. And now what do we want to assert in this test? Let's assert that context.publishedMessages.length is equal to 1, should publish order shipped, and assert that, given that the saga will be over, we want to assert that the saga is completed. So let's try these tests now. Oh, it failed. What's going on? Should publish order shipped, expected 1, but was 0. What's actually going on there? Well, the answer is that we never actually published order shipped. So if we go back to our shipping policy and we come down to the block of code where it was actually supposed to publish that message, where data is where the order is both placed and billed, all we ever did in the previous webinar was log an info message and mark as complete. We never actually published that order shipped. So we need to do that quick. So let's actually come over here to messages and we'll add a new class. We'll call it order shipped. That can be a public class. And we'll implement iEvent. And that needs to come from NServiceBus. By the way, you may have noticed that we have in these projects now, we have implicit usings enabled, and in NServiceBus 8, we will be adding an implicit using for the NServiceBus namespace. So you won't have to do this anymore with NServiceBus 8. So we'll add public string order ID, and it's cranky with me because we're using nullable reference types, and that won't be non-null by the time you exit the constructor. So I actually have to say string ? To say that string could be null. So now we can go over to the shipping policy and we can change this how it's supposed to be to say await context.publish new order shipped. And we can do order ID equals, we get the stored order ID from the saga data, and that's how we ship it. And now we're doing async on this, so we can take out the return task completed task. And now let's see what our test does. So now we run our test and it succeeds. So one thing you may have noticed about these tests is there's a lot of things to assert on, and that can be really rough. And you might be missing something in one of these other collections that maybe you should have asserted on and didn't even know how it was. So I would actually like to introduce you to a package called verify.NServiceBus that was created by one of our NServiceBus champs, Simon Kropp. And it makes testing even easier by allowing verification tests or approval tests on these type of tests. So what we're going to do is first, I want to kind of show you the README for verify NServiceBus. You need to kind of follow the instructions in here because it requires a module initializer. We have to put this code into our project somewhere for verify to know how to deal with our testable message context and other stuff like that. So I will hide that. And the first thing we're going to need to do is to add the libraries. So we're going to do .NET add to shipping.tests, the package verify.NServiceBus. And then we're going to also do .NET add to shipping.tests package verify.NUnit. So verify is a package that does approval tests. Verify NUnit is the adapter for using NUnit. There's also one for XUnit and other frameworks. And then verify.NServiceBus is the one that has that knows how to represent the testable message context and other stuff like that. So in our shipping tests, one thing that if you actually look at the transitive references to these verify things, you can remove NUnit because it's a dependency of verify NUnit. And you can remove NServiceBus testing because it is a dependency of verify.NServiceBus. And then that prevents you from getting some, duplicate reference things that might happen. So that builds. Now we need to create that module initializer that we looked at in the README. So I'm going to add a class, module initializer, very tiny CS, and I'm going to copy and paste that in. So this has got the module initializer attribute, which tells .NET basically to run it when it starts up. And in the initialize, it's calling this verify NServiceBus.enable. Okay, can close that. Now we can take this test in shipping policy tests, and we can remove all of our asserts because we're not going to need them. I'll just comment them out. And instead, we're going to do await verify context. And if you're wondering where that method is coming from, it's actually part of the class verifier, but the excuse me, the verify and unit packages are registering implicit usings for the verifier and a static using for verifier.verify. So if you were still using .NET 5, or if you were still using Visual Studio 2019, you'd have to do verifier.verify, but this saves us a few keystrokes, so that's great. So let's run this test again and see what happens. And it's gonna fail, I'll tell you that right now. You can see that it failed, but what happened is it popped up my diff viewer, and it's giving me a JSON representation of what happened in that message handler context. So if I sent messages, there would be sent messages. All I did is I published a message with order shipped. And the deal is you take this and you copy it to the right and you save. And what that does is you now have a, this is the name of your tests, .verified.txt, where this is .received.txt. So when you are running the test, it generates the new version by converting the context to a JSON representation. And then it does a comparison. And if it matches what you already have committed to your repository, then the test passes. So now if I were to run it again, it will succeed. But I don't know if you noticed, but I'm actually going to go to the File Explorer and I'm going to delete that file. I'm going to delete both of them because I want to see that diff viewer again. So let's rerun the test. And I don't know if you noticed, but it says order shipped and there's nothing inside of it. This is actually really good because this shows something that was actually missing from our test before because we had a missing assert. It doesn't have an order ID in there. And the reason is, unfortunately, a current limitation in our test infrastructure. You basically have to set up your Saga data exactly how it should be before the test runs. And in this case, that means the data should have had order ID equals 1, 2, 3, 4, 5 in it. So now if we run the test again, we will see more what we expect, that we get an order shipped with an order ID property that's 1, 2, 3, 4, 5. So we can copy that. This file gets committed to the repository. And then when we run the test again, everything is cool. I am actually currently working with a team right now to make this better. So you don't have to know exactly how NServiceBus handles sagas in all of these conditions. And you can do a little bit more black box testing of your NServiceBus sagas. So I think that's pretty exciting. Of course I do, I'm working on it. So keep a watch out for that. It'll be released sometime soon. Okay, so now we've finished with testing. We didn't really show a handler testing, but a handler is just a saga with no state. So you don't have to worry about this stuff. You just create a new version, you new up your handler and you execute it and it looks the exact same. So that's good enough for a quick webinar, because otherwise we won't be able to get to behaviors, which is next. So behaviors are a feature in NServiceBus that allows you to amend the message processing pipeline to your own liking. And it's really kind of an advanced get out of jail free card kind of feature. because I haven't really run into much of anything that you can't customize with a behavior. They're really great for doing sort of cross-cutting things. So instead of having a message handler that first logs when it starts, and then it tries to do like a set up something and create a whole bunch of things, and you sometimes find these message handlers that are 100 lines long, and the actual business logic is only like 4 lines stuck in the middle of that. That's what behaviors are best at, and I'm going to show you how to build one right now. So first, I'm going to create a conventions project. So I'm going to do .NET new class lib name retail system .conventions. So a lot of times I see companies basically doing company name .conventions. So I suppose we would do particular .conventions. And what that means is it's conventions for how endpoints are supposed to run within your environment. So we'll also do .NET solution add retail system .conventions. And we'll do, let's see, we want to add NServiceBus to that. So .NET add retail system conventions. We want to add the package NServiceBus. And what did I do wrong? I misspelled it. .NET add retail system .conventions package NServiceBus. That's better. And we will also add the conventions to the shipping project. So we're going to kind of test this out in the shipping project. So we'll do .NET add shipping. We'll get a reference to retail system conventions, retail system conventions.csproj. Cool. Now we have what we need. And reload the solution. Retail system conventions. So we've got one class in here. Well, let's look at the project. I always like to look at the project to make sure everything looks like I intended to. And I've got my basic settings here and my NServiceBus dependency. So I'm good to go. So I'm going to rename this class. And we're going to do a very simple behavior. It's just a timer behavior. It's kind of the simplest thing that'll show how to build these things. And so now that it's been renamed to timer behavior, I'm going to just right away add using NServiceBus.pipeline. And that's how you know you're doing something advanced in NServiceBus. We try to put all of the common stuff right in the NServiceBus namespace, but then more advanced stuff is hidden in deeper namespaces. So welcome to advanced, I guess. So in this class, we're going to inherit from behavior of type, and I'm going to put in I invoke handler context. And I'll tell you what that is in a second after we get this implemented. So the context, a behavior always uses a context, and the context describes basically what stage of the pipeline that you are wanting to attach your message to. So for example, the incoming message pipeline has what starts off with an I transport receive context. And if we start looking at what's in here in IntelliSense, the transport receive context has a message, the physical message being processed, and a builder for creating dependencies, and not a lot else because it's the earliest step in the process. But then if we step up to the next part is the I incoming physical message context. And this is when the incoming message is basically an amount of bytes basically represented somehow, either as a string or a memory or whatever. So in this case, now we've actually parsed our message headers. So I believe we have message headers available. So this is a great place to do things that require the byte stream and the message headers, like dealing with encryption or message signing or even converting the bytes on the wire into a different format, compression, whatever you want to do in there. Next up is, after incoming physical message context, there's incoming logical message context. And this is after the message has gone through deserialization. So at this point, we can look at actually updating the message instance to something else. We can do sends and replies and all that stuff. We can look at the headers, the message handled, the message ID. There's a lot of things we can do here with the object that actually represents the message and the headers. And then lastly, and the one we are going to use, which I already showed here, is the invoke handler context. And this is basically right before we invoke your user code in your iHandleMessages class. So from here, oh, and I should also mention there's also an outgoing pipeline, and it has a bunch of context too. There's an outgoing send context, an outgoing publish context, an outgoing reply context. Those all kind of wrap into outgoing logical message context, which is kind of the mirror of the incoming logical, an outgoing physical message context, which mirrors the incoming physical. And then there's a routing context and a batch dispatch context and a batch and a dispatch context. A lot of places to hook on functionality. But now let's return to the invoke handler context and let's fill in some code. So in here, we have the context and we already looked at all of the things we can access in here. And then we have this next thing. And the point of next is we want to invoke it when we want to invoke the rest of the pipeline. So in our case, that means wherever we want to actually handle or process the user code in the iHandleMessages class, that's where we want to do that. So for this specific behavior, we're going to need a logger. So let's do static ilog, and didn't want that. It'll help me eventually using NServiceBus logging. Log equals log manager dot get logger, and we'll give the type timer behavior. So now we have a logger. So this is a timer behavior. We're basically timing how long the message handler takes. So we're going to create a stopwatch equals stopwatch. And that's actually the class that we want. So if Visual Studio could help us, that would be great. Using system diagnostics, stopwatch.start new. And then we want to get rid of this throw. We do not want to throw an exception. We want to do a try finally block. Because even if we throw an exception in our message handler, we want this thing to happen. So within the try, we're going to do that wait next. And within the finally, that's where we say stopwatch, stop. And then we're going to say log.info handling, and we can look at our context here, context dot message being handled dot get type dot full name in context dot message handler dot handler type dot full name. Then we can just say took, and then the stopwatch lapsed milliseconds, and label that as milliseconds. See the end of that line. So handling the message type in the handler type took a number of milliseconds. And that's basically it for the behavior itself. The only other thing we need to do is we need to register it. So in shipping for now, we can go to program, and in our endpoint configuration, we can say endpoint configuration dot pipeline dot register. And there's a bunch of choices, including something that uses something called a register step that you see there. But the easiest way to do this right now is to basically find the overload where you just create an instance of your behavior, assuming it's a singleton, and give it a description. So we're going to do a new timer behavior. And then the description is provides timing for each message handler. And we need to get a using for the timer behavior from our retail system.conventions. So this is probably the last demo we'll have time for. So I'll start. And it'll be slow building all the new code I just wrote. So we're looking at our shipping window and we want to see those timers come out. So let's place an order. And so now we see here, handling messages order placed in shipping policy took 48 milliseconds. Handling order billed in shipping policy took 51 milliseconds. So we don't have to put that kind of repetitive logic into each one of our message handlers. Instead, we can create something that's reusable, and we can register it with our endpoint at the endpoint config. And in the future, maybe I'll show alternate ways of organizing that to make that easier to do. But for today, I think that's about all the time we have. So, William, do we have any questions? Oh, before I get to questions, I want to mention that if you want to learn more about, I don't want to share that, no. If you want to learn more about not just the details of how to create an NServiceBus system, but really the theory behind how to do it effectively, I really recommend our absolutely free Distributed Systems Design Fundamentals course, which is several hours of free training directly from Udi Dahan. You can get to it at this link, the go.particular.net/NSB webinar.